We've got a lovely integration question today, at least according to me. We're integrating 3 over x minus 1 times by 3 plus 2 root x minus 1. Luckily, they give us a substitution, so we don't need to think of it ourselves. Main thing to do with substitution is we need to differentiate both sides, like this, and rearrange to get a dx in terms of du. If I times by du on both sides, dx is 2u du. So what I'm going to do is I'm going to rewrite the integral and I'm going to substitute in all the u's instead of x's. So I'm going to change the dx to 2u du. And in the denominator, instead of x minus 1, it's going to be u squared plus 1 minus 1. Like this. The 3 plus 2 square root is the same, and instead of x minus 1, I'm going to do the same thing, u squared plus 1 minus 1. You notice I've not done the limits yet, so let's do that next. The original integral in terms of x. So when the original integral limit is 5, then what's u squared plus 1? It must be 5. If we then solve this, we find that u is equal to 2. Similarly, if x is equal to 10, u squared plus 1 is also equal to 10. And therefore u will be equal to 3. I've chose the positive square root. You could choose the negative one, but it would make things more complicated. So the limit's going to be 2 and 3 in my case. So let's simplify a bit. The numerator will be now 6u du, and then in the denominator, the 1 minus 1 will cancel out. Similarly, underneath the square root, the 1 minus 1 will cancel out, so it will be the square root of u squared, and that will be just u. Comparing this to the answer now, it's looking quite close. But there's one more thing to do, and that's to cancel out a u in the numerator and a u in the denominator, like this. That gives us 6 du over u times by 3 plus 2u as required. We're not done there. There is more fun to be had. Now we need to find the actual value of the integral in terms of ln. If you don't know already, you have to be thinking partial fractions when you see 1 over u times by 3 plus 2u. Partial fractions put it into the form a over u plus b over 3 plus 2u. And if we multiply both hand sides by the denominator here, we're going to get 6 is equal to a 3 plus 2u plus b times by u. And we can strategically think of values of u, which will give us a and b. For example, 0. If we sub in 0, we'll get 6 equals 3a, and therefore a will be equal to 2. And if we sub in now minus 3 over 2, that will make the a bracket 0, which means that 6 will be equal to minus 3 over 2b, and therefore b will be equal to times by 2 divided by minus 3 minus 4. So now we can start integrating. So the original integral would be equal to, from part A, the integral with u instead, like this. I'm going to put the du on the end. It looks a bit neater, but it doesn't actually matter. And now I'm going to substitute in my partial fractions. 2 over u minus 4 over 3 plus 2u du. The first one you should recognize as ln. It's 2 lots of ln of u. Whereas the second one is a bit harder. The derivative of the denominator is 2. So if there were a 2 in the numerator, we'd be quite happy. And instead of writing it as 4, I'm going to write it as 2 times 2. Now the derivative is exactly the same as the numerator, so it's minus 2 lots of ln 3 plus 2u. It's a really nice trick. If you're not too sure about that, you can use another substitution with 3 plus 2u, and you get the same answer. We're just subbing in the limits now. 2 log 3 minus 2 log 9, and then subtract all of 2 log 2 minus 2 log 7, like this. If we make a bit more room, we'll be able to simplify this answer. I'm going to bring up the 2 into the logarithm, so it's going to be logarithm of 9 minus logarithm of 81. And we're going to subtract all of logarithm of 4 minus logarithm of 49, because it's 7 squared. Using our laws of logarithms now, 9 over 81 is a ninth, and 4 over 49 doesn't really simplify, so I'll leave it like that. And finally, we can subtract the logarithms, which means times by the reciprocal of the second. And then we get our final answer, ln of 49 over 36. Which means a is equal to 49 over 36, which is indeed a rational constant. And here are 2 more.